Hi, welcome back to this channel. We are continue with chapter 5.4 phase diagram. So first we need to know the definition for phase, triple point, critical point. Then from the phase diagram, we are going to identify triple point and also critical point. We are able to draw the phase diagram for the water and carbon dioxide. For your information, the phase diagram for other substance also similar with carbon dioxide. Then based on the phase diagram, we are going to look for the difference and also able to explain the anomalous behavior of water. So the anomalous behavior here basically is referred to density of ice is lower than density of water. Next, we are going to discuss about the physical phase change at the constant pressure. So another term for constant pressure is isobaric. Sometimes the question may ask you the phase change at constant temperature, which another term is referred to isothermal. Now, let's start with what is the meaning of the phase. Basically, there are three physical phase: solid, liquid, and also gas. So the definition for phase is a part of the system which are separated by a distant boundary. So boundary in Bahasa, we can say that it is a sembadan. So if you cannot see any boundary, means that there is only one phase. If you can see there are one boundary, means that there are two phases. So let's continue with the example over here. State the number of phases for each of the following system. Ethanol, water. So both ethanol and water consist of hydrogen bond. So means that they are going to mix well together. So if they mix well together, we only able to see one layer of the solution. So therefore, we can say for the mixture of ethanol and boundary, we only can see one phase. Question B, benzene and water. Benzene actually is an example of oil. So oil and water cannot mix well together. So you will able to see there are two layers. So therefore, the phase is two phases. A mixture of nitrogen gas, oxygen gas, and also carbon dioxide gas. So when we look around the air surrounding us actually is a mixture of oxygen, nitrogen, and carbon dioxide gas, and also some of the argon gas. However, we cannot see any boundary of these gases. So that's why for mixture of gas, the phase number is 1 as well. Next one, the aqueous nitric acid is at equilibrium with its vapor. So means that for this system, they are going to have two phases. One is the nitric acid in the phase of aqueous. Another one is in the vapor. So we can see there is the boundary to differentiate the aqueous phase and also the vapor phase. So that's why this mixture consists of two phases. Now let's continue with the extra exercise. After the tutorial question number 1, we are still practicing how to determine the number of phases in the system. Again, mixture of gas. Okay, this time they didn't give us any example of the gas. Okay, but as I mentioned before, when we look around us, we cannot differentiate which part of the gas is nitrogen, oxygen, carbon dioxide, or even argon gas. So the phase only one. Next, the mixture of oil and water. Oil here is similar with the benzene that we discussed previously. So for this system, there are two phases. Next, boiling water. Because the water is boiled, so at the same time, both liquid and vapor are present, so we are able to see they are two-phase. Mixture of alcohol and water, like previous question tutorial 1a, alcohol and water both can form hydrogen bond, so they are going to mix well together and only one layer will be seen, so there is only one phase. Last question, a glass of cola with the ice. So cola is in the liquid form while the ice is in the solid form. So at here you can see both phase clearly with the boundary, so there is two phase for this system. Now let's continue with the phase diagram. Basically, this is the example of phase diagram. So when we look at this phase diagram, it is quite similar with a graph, at where we will define that phase diagram actually is a plot at where is pressure versus temperature. So in this phase diagram, we are able to identify melting or freezing curve. Like showing in the phase diagram here, from the left side is the solid phase, in the middle is liquid, and then the right hand side is gas phase. So the line between that separate the solid and liquid phase will known as melting or freezing curve. So this is referred to OB line. Next, sublimation and deposition. As we know, it is referring the physical phase changes between solid and gas. So which is referred to AO line. Next one, the line between liquid and gas, which is OC, actually is referred to boiling and condensation. Next, from the phase diagram here, actually we are able to identify the triple point. So as shown at the name, triple means three. So basically the three here is referred to the three phases of the substance, solid, liquid, and gas. So this point O is referred to triple bond. At this temperature and this pressure, the substance will be present at solid, liquid, and gas mixture. Last is the critical point, at where is the point C over here. So when we look at the phase diagram here, we will notice this critical point is in between the liquid and gas. So now we are going to continue with the definition of triple point and critical point. So this is the definition for the triple point, the temperature and also the pressure at where all the three phases exist at equilibrium. The three phases are including solid, liquid, and gas. While the definition for critical point is also referred to the temperature and pressure at where the gas cannot be liquefied even though pressure is applied. In simple words to understand is, at this condition, liquid and gas cannot be differentiated. At where sometimes you can see the word fluid. Let's continue with tutorial question number 2a. Sketch and explain the phase diagram for carbon dioxide. So this is the example of the phase diagram for carbon dioxide. So basically, triple point and also critical point are specific for each substance. So in our syllabus, we are only focused on carbon dioxide and water. So possible, remember the critical point and also triple point for carbon dioxide. So the shape of the carbon dioxide and the shape of the phase diagram for the carbon dioxide and other substance are similar because we will notice that the BO line, which is over here, they are always in positive slope. Now let's look at the phase diagram of the water. Basically, we will notice that the BO line for water is negative slope. So this is the main difference between the phase diagram of water and also carbon dioxide. As usual, the triple point and the critical point are specific for each substance. So remember the triple point and critical point for water and carbon dioxide. But for the shape of the phase diagram, the BO line for water is negative slope, while the BO line for the carbon dioxide and other substance will be positive slope. Question 2b. Compare the density of carbon dioxide in the liquid and solid phase. Because the BO line is positive slope, so the density of the carbon dioxide will be in solid is higher than the carbon dioxide in liquid. This is different from the water. For water, density of ice, solid, is lower than density of water, H2O, in liquid form. Now, let us describe why water show anomalous behavior. Okay. Anomalous in Bahasa we can consider like luar biasa. Okay, special behavior. Generally, all the substance show melting point increase when the pressure is increased. That's why just now we say that the BO line is positive slope. But melting point of water will be decreased with the increasing boiling point. So that's why you can see from the phase diagram of water, the BO line is negative slope. This is because when solid water means that the ice is melt, its volume will be decreased. This is what we discussed in chapter 4 before. Because due to the solid density is lower than the liquid density. Now let's compare the difference between phase diagram and phase diagram of carbon dioxide and water. So like mentioned before, the triple point and critical point are different for each substance, including the carbon dioxide and water. The main difference between both phase diagram of carbon dioxide and water are the slope for the melting and freezing curve, at where carbon dioxide will show positive slope, while for the water it shows negative slope. Let's check out here. Negative slope of BO, freezing curve for water, and then positive slope for the freezing curve of carbon dioxide. Tutorial question number 3. These are the phase diagram of water. How we know? Because the freezing curve is negative slope. Next, question A. Which curve represents equilibrium between ice and water vapor? So if the term equilibrium ice and water vapor means that at this condition, both solid and also gas phase are present. So in this case, we are going to know that these are referred to the sublimation. So if this is the sublimation process, so we are going to look for the sublimation line. So as we know, the left region here is referred to solid, middle region here is referred to liquid, and the right side here is referred to the gas. So the curve between D and B, the line DB is the line that will separate the solid and liquid. So the answer will be DB curve. Question number B. State the phase change when a sample of E is heated. So when E is heated, then we know the temperature is increased. So according to the phase diagram above, the arrow supposedly going to move from left to right, like mentioned in the question, from the point E point until the point F. So point E is over here at this moment. At this point, water H2O exists as the solid form. At this point, solid and liquid, and here liquid, and then over here is liquid and gas, and at the F point it is gas. So from this simple example, we can say that if the point is on the curve, any point on the curve, they are going to have two phases. While if the point is in the region, it is referring to one phase only. Now, look at next question. C. State the phase change when a sample at point I, so point I is over here, is compressed. Okay, sometimes maybe the question doesn't let us know. It will move from where, like the question B and C, but they just let us know at point I is compressed. So you have to understand, if compressed means that the change of pressure happens at where the pressure is increasing at constant temperature until point J is reached. So this question is very kind, they let us know. It's from I to J. So at where, like what we predict just now, the pressure is increasing. Okay, so for this one here, at the I condition, the H2O is in the gas phase. At this point, again, like just now we mentioned, if on the curve, two phases are present. So in this case, both gas and liquid present, and at the point of J, only liquid. Next question, donkey. Name the point at which the BC line intersects at 1 atm. So we have to look for the BC line. So where is the BC line? The BC line is over here. And then it will intersect at 1 atm. So pressure is at the y-axis. So let's say this over here is 1 atm. So what does this mean? So BC line basically is a curve separate between solid and liquid. So it is either melting or freezing point. But because of the question emphasized over here is at 1 atm, so then we need to add on one more term, which is normal. Any melting, freezing, or any physical change process when happen at the 1 atm, in front of it you have to add one more word, which is normal. Last question. BC line has a negative slope. Explain. So normally if we want to explain this question, we are going to let people know that because the melting point decrease when pressure increase. Why this can happen? Because density of ice is lower than density of water. Continue with tutorial question number 4. Substance X has a triple point at 18 degrees Celsius and 0.5 atm. The normal melting point and normal boiling point are 20 degrees Celsius and 180 degrees Celsius respectively. So as mentioned just now, normal melting or any point at normal condition means here refer to at 1 atm. Sketch the phase diagram for X. As we know, phase diagram is a plot at where so-called left y-axis is referred to the pressure. Then please remember, including the unit for the pressure, atmosphere. And then the x-axis is referred to temperature in the unit of degrees Celsius, okay? In the unit of Kelvin also, okay? Then we will continue with 3 line, which actually means that the separation between the solid, liquid, and gas. So as we know, there are 2 types of phase diagram. One is positive slope, and then another one is negative slope. Negative slope is a special case for water on a H2O. Others will be positive slope. So since X here didn't mention it is water, so we will treat the S as other substance, and we are going to draw the phase diagram in positive slope. So now we are going to start with the 3 line. So remember, don't start from the origin because of the freezing curve is the positive line. So you have to show positive. So after you draw these 3 lines, then you have to label from the left to right. Left is referred to solid region, followed by liquid region, and then last is the gas region. So because of you already understand, this is the triple point. So then the triple point is at 18 degrees Celsius. So means that you have to drop down here, label 18. And then to the left side here, it is 0.5 atm. And then better that you are label triple point in the phase diagram. Next, like we mentioned just now, normal refer to 1 atm. So you are going to write down intersect one line at 1 atm. So when we intersect the OB line or the freezing curve going down here, we are going to label this is 20 because in the question mentioned melting point is 20 degrees Celsius. Okay, so this curve is showing the separation between solid and liquid. So when the solid change to liquid, it is a melting process. Continue with the boiling process, refer to liquid to gas. So we continue to intersect the line over here. So when touch the boiling curve, we move down. And then we are going to label here 180 degrees Celsius. So this is the phase diagram that we're going to sketch according to information given in the question. Let's look at 1 as well as a 5. This is the phase diagram for carbon dioxide. Question number 1. Is carbon dioxide ever in liquid phase at 1 atm? So the graph here already show 1 atm. So means that we just try to make an intersect line over here. So you will notice that this phase, the substance or the carbon dioxide, at 1 atm, they only will pass through the solid phase and also the vapor phase. So means that the carbon dioxide never as liquid at 1 atm. So that's why in our surrounding, we are not able to see any carbon dioxide in the liquid phase. So the answer is no. Okay, question number 2. What is the normal sublimation point? So like just now we mentioned, if normal refer the pressure at 1 atm, sublimation means that is the changes between solid to gas. So that's why we try to find out the sublimation curve, which actually is referred by the AT line. Okay, so at 1 atm, so we make the intercept line, and then going down here, the temperature is referred to negative 78 degrees Celsius. So this is the normal sublimation point for carbon dioxide. Number 3, carbon dioxide at negative 30 degrees Celsius and 10 atm. Okay, so negative 50 is over here. So maybe we will predict that negative 30 is over here. And then at 10 atm, so this is 5.2. So we double the region. So basically, this will be the condition at where the carbon dioxide is at negative 30 degrees Celsius and also 10 atm. Is slowly heated, like just now we mentioned, if heated, temperature is increased. So based on this phase diagram, we are going move to the right. And then now at constant pressure, which is another term for constant pressure, is isobaric, and then state the change of the phase. So try to look at here, we are at the liquid, and then we keep on heating until one moment. At here, we will get the mixture of liquid and gas. If we continue do the heating, then we also will, the carbon dioxide will exist at the gas phase. So next question is question number 4. So at the same point, negative 30 degrees Celsius and 10 atm. But this time, it is going to decompress. So decompress means pressure is decreased. So if pressure decrease according to here, we are going to move down to the phase diagram. We are going to move going down. So same case as well, from this point is liquid. So when we decompress, the pressure is getting lower and lower. At this point, the carbon dioxide will be exist as liquid and gas phase. And then if you continue to decompress, they will exist in the gas phase. Now let's proceed, still using the same phase diagram, but we are going to proceed to question number 5. On the planet X, the atmosphere pressure is 10 atm. So I think just now we roughly already mentioned, this is the 10 atm, and then this is around the negative 30 degrees Celsius. Okay, 10 atm. Okay, so what the question is saying, and the normal temperature for this planet S is 250 Kelvin. So we have to convert them to degrees Celsius by minus 273. So we'll get negative 23 degrees Celsius. So what is the stable phase for it? So negative 23 is slightly right side of the this point. So basically we still can mention that the carbon dioxide at 10 atm and negative 30 degrees Celsius is in liquid phase. Okay, so means that over here it is over around negative 23 degrees Celsius lah. So the phase is still liquid. Next question, number 6. What is the melting point of the solid on the planet X, but the pressure is 10 atm? So melting point of the solid, so is the change between solid and liquid phase. So this is the melting curve that we refer. So at that end atm until it touch the melting curve. So and then we're going down here. So this one will be the melting point for the carbon dioxide at planet X. Last question. Carey used carbon dioxide to extract the organic compound from a rock bed he carried out the experiment at 10 atm, 320 Kelvin. So again, we minus 273 Kelvin, we will get the answer is 47 degrees Celsius. So what is the phase that carbon dioxide is carried using? So again, still at 10 atm, but this time is 47, so means that it will be at the left hand side. So means that continuous going down. So basically, this phase is referred to the gas. Okay, so that's all we need to discuss with you. So beside for the subjective question, these are the answer for the objective question in your tutorial question. So thank you for watching this video. We are going to continue with chapter 6 in next video. Thank you.